Actually, we are now opening up the session for a discussion. So if there are any questions from the audience, please uh, post your questions and we can actually take it up one by one and have your questions clarified. Uh, in the meanwhile, let me also start the session with some questions. Maybe first I would just like to have some questions to Dr. Karthik, specifically related to your presentation,
Yeah.
where I think you were comparing the degradation profiles of the polymers using the micro UV analyzer coupled with GC mass spec and also the weather meter.
Yeah.
And I think in some of your slides, slide 24 or 25, you actually show that the power, the UV flux, ultraviolet
Yeah.
radiation flux, or the intensity was actually seemed to be more the for the micro UV
Yeah.
system. So is that due to that higher power that you are actually finding a faster decomposition at shorter period of time, whereas the weather
Mm,
meter seems to have a lower power?
no, 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 because actually, finally, we are actually normalizing the flux. Okay, so the main reason is we are able to do this in microgram scale, whereas the weather meter require few grams of sample. So that's why the duration is it's becoming longer, because you do not get so much of light onto the sample, so the duration has to be extended to get the complete flux. Yeah. So otherwise, they have to really invest big money on the UV system with a high watts power. So just to make it economical, they have a simple setup, but they have to do it for longer. Yeah. Because here the benefit we are seeing, we are using micro amount of sample, and we are able to spot the UV light directly onto this piece of particle. That's why we make it more effective and make it fast. Yeah.
Got it. Got it. And that actually brings to the next point about whenever we talk about low sample mass, and I think I also request the other two speakers to turn on their cameras so we can have a effective discussion. So I think everyone can share their views on some of these points. Uh, when you say that the sample mass has to be only of a few milligram or microgram scale, right? The natural question then is how much representative can the sample be, especially if the sample is very heterogeneous. And I think this may be applicable both for pyrolysis studies, where now we are actually expanding the application of pyro GCMS to studying more complicated feedstocks like solid waste and so on, where a small dot or a pinch of sample may not be really representative of the whole solid waste, or even for your case of weathering of your samples, right? So how do you really justify and also try to convince people on the field that this could still give very valuable information? and
Okay.
and
Yeah.
and
Maybe.
I think all of you can respond and share your views. Yeah,
Yeah,
maybe
I
Karthik
will.
first.
Can I start first? Yeah. Okay. Okay. Thank you. Yeah. Yeah. It's a very good question and very important question, because when we say we can do it with small amount, it's important we take the right sample, a representative sample, because sometimes if our lab table is not clean, we may take some particle which is not real sample. Then the whole story changes. So it's important to have the right representative sample. And one of the challenges that even as a user people may be facing is, yeah, how to make the homogeneous samples. Particularly if you are talking about contaminated sample or the failure sample, you have to see how you can select that affected portion. Okay. So previously we used to do all this through our mechanical approach, and where we do the better job with our experience. But now, to simplify this, okay, we have come up with this cryomill, which actually allows you to take a few grams of sample from this any object, and you powder it. So once you pulverize, then the homogeneity is actually improved. Then any small piece amount of sample really can give a good representation of the material. However, when there are certain cases where we are unsure about that, we always recommend to have few replicate analysis to see whether your observation is consistent. Yeah,
Yeah. Thank you.
yeah, Michael San, and Anisha, you can share your
If you
thoughts.
have any other views, maybe you can share.
I think that Karthik-san already answered your question. I don't have anything to add. I think now we have the new the
Yeah.
mill also that makes it more the homogenization is a key point. Or if this is not the ultimate result, then we also have to do duplicates or triplicates of the analysis. So that's
Yeah. Yeah.
I mean, we always have that, not an issue, but the fact that we have to work with small sample amounts when we are using the pyro. That's something that
I
we cannot
agree.
completely avoid issue.
Yeah. I think the cryo mill makes a big difference here. So you can actually homogenize the particles, homogenize the sample to fine particles. But I think this is something that could be studied, because our experience with a lot of biomass related research is that typically with a lot of ash or inorganic laden sample, right, as you actually do this crushing, right, a lot of this crystalline inorganic particles tend to go to the fine particle phase. So in that case, sometimes you may even find that the fine particulates have a lot of ash or inorganics in it. And for some applications, like biomass conversions, we find that these ash particles could also play a catalytic role. So, but that's of course left to more deeper R&D. Again, a quick prompt to the participants to post any questions,
Yeah.
because I'm not able to
Prof,
see any
actually,
questions in the chat box.
I'm sorry. Yeah, Professor, sorry to interrupt. Asti actually listed down the questions, okay, because there are some questions, and she will display in this PowerPoint. And maybe, yeah, if you are ready to go over that, maybe we will request her to display one by one.
Oh, sure. Yeah.
Yeah. Asti, please post those questions, whatever you have so far.
Yep, that's the first question for today.
Okay. So,
Michaelson, do you want to answer this?
Uh, I heard this kind of question several times. But now that is the advantage, that having very small sample amount, that as far as I am aware of, there is no concerns about if you are analyzing PVC and HCl, that really the system or the column or so will be deteriorated by this compounds. So what this is,
Yeah.
it comes up quickly but I think that is not a big issue for us.
Yeah, mainly because we are handling small samples, but again, yeah, it has to be watched, so we cannot take it granted. But mostly we do not see this as a big issue, because we are generally using very small amount of sample, and wherever we require, we can also play with the split ratio to minimize the impact.
Yep.
But yeah, it has to be watched absolutely.
I can also give my couple of
Yeah,
pieces on this. So I mean, HCl formation from plastic is quite rare, especially only when you have polyvinyl chloride as the main plastic. Only then you have the formation of HCl as a reaction product, pyrolysis product, and that's when you have this as the main thing. Whereas with most of the the conventional thermoplastics which are non-chlorinated, I think this is not an issue. But only with very specific things like PVC or PVDF and so on.
Sure, sure. Yeah, that's a very valid point. Yeah. Okay, Steve, move on to the next one, please. Oh, it's a long one. Okay,
Bottom
Michael
up
Sam.
quantification and measuring.
Actually, Dr. Michael already answered that.
Yeah, but it is just answered one-to-one, so I can maybe for the audience
Yeah.
Yep,
I
yep.
repeat my
Yeah,
answer
yes.
because it's quite a common question what can come up, because we have this small cups, huh? And then the users doing or want to perform microplastic analysis, wondering, okay, how can I put the sample inside? And in very often the last sample preparation step is a filtration step on a glass on a filter, obviously a glass fiber filter, inorganic filter. And then the question is, how can I put the sample from the filter into the cup? But the solution is easy, that you put the whole filter, including the filter cake, into the cup. So basically, you are folding. There's a little bit. You need to have some practice maybe, but you are taking two tweezers, and you can really fold the small filter, which should not be bigger than maybe 1 centimeter or so in diameter, to make a small cake, and then put using the tweezer the whole filter, including the sample, into the filter cups and pyrolyze them together, because inorganic material do not disturb the analysis. Another point here is that you can, let's say, put some drops of alcohol before that to make the glass fiber filter less brittle, so it's easier to fold and to put in the cup. And the other thing is, yes, but we have also performed already that you can use um, cryomill to make a powder out of the filter. And if you have, that is also an advantage if you have bigger filters like 4 centimeters, that you can cut it in sections and then filter these sections separately and put the whole thing together. Of course, then there is always a small risk losing information, losing some material and so on. But that is a second approach what you can do. Any other
And
ideas?
just one quick point is also that I think cryomilling can also be used for slightly bigger samples, even if the samples are in the form of beads or pellets of few millimeters to a centimeter size. It can still be used, and it is quite effective. That's also been our experience.
Yeah. Yeah.
Maybe next question.
Good question. Unfortunately, I don't have the data ahead of me, but I can tell you that the quartz, because we have in the microplastic calibration kit, we have the polymers diluted in an inorganic diluent like calcium carbonate and quartz. And I think the quartz powder is 30 micron particle size. When we prepare this kit, only PE and PP are used as solid polymers, so that means this must be grinded in very small particles. But I don't have maybe some other have right now the particle size in mind. I don't have it, but I can ask for that. But the other polymers are solved in specific organic solvent and then put together as a mixture and then let the solvent evaporate. And so that means these particle sizes are much smaller, of course, after evaporation of the solvent. That is what I can say on my side. Any other comments?
Yeah, I think at this moment that is the best answer. So yeah, in general we can say our particle size of the standards are around like 30 microns. Yeah, because some of them we dissolve and put it into the this particle, so they are attached to it. So yeah, I think in terms of the particle size, yeah, that's the range. Yeah.
next.
Next question, please.
Yeah. Yeah, that is the purpose of the PY system, because yeah, if you do not have a pyrolyzer, you cannot do solid sample. You can do it because usually you do the headspace. Headspace allow you to do it. Also, even if you have a TD system, you can also introduce solid samples. But headspace and TD system can take you to only certain temperature, okay, like 350. But when you really want to heat above 350 for a sample like polymer, then you really need a pyrolyzer. So pyrolyzer can do multiple things for you, like not only the pyrolysis, it can also do TD, it can also do even with the chemisorber, it can do the solid phase micro extraction. Even we have a small setup that allow you to do the air sampling, also the purgeon trap. So multiple things can be done with PY, but the PY is the key application of this. Yeah, move on to the next one, please. Yeah. It's a very good question. Unfortunately, I don't have the clear answer for this now. Please drop me an email. So I will. There are some methods, but how far our testing protocol is aligned standard is something I'm not pretty sure. But yeah, we can discuss offline through email. Yeah.
Question,
Oh,
please.
interesting. This question comes from my customer in the Czech Republic, because they are running a tandem microreactor.
Very.
But this kind of combination, oh no, I don't think so.
At least we have never seen coupling UV radiator.
No, no, Michael, sir, I will answer if you don't mind. Okay, because if the intention is only to use one of the reactor, because we have a customer back in India where they are using the tandem reactor as a single reactor like PYGCMS type. In this case, you have to leave the second reactor empty. Okay. But in terms of the performance, we cannot guarantee because there is another reactor, some connections, interface. So, but in most of the cases, you are able to get a similar reaction. So, to answer your question, in principle, it is possible, but if you want to do photo and catalytic degradation, it's a different story. So that one has to evaluate. Yeah.
Yeah, I mean, it's also a question
I
about
think
the
that's a
technical design also. I mean,
Yeah.
lengths and everything, this UV sampler and this protection tube thing must really fit. So I'm not 100% sure.
Yeah, absolutely. Yeah, yeah. We have to refer back to our team. Yeah.
maybe Frontier should
Correct.
look at this because I see that looking at your polystyrene oxidation example using UV UV radiation. I think this could be a very good application where you do this oxidative or partly mild oxidative degradation followed by some catalytic upgradation of vapors to some valuable products. So that could be a possibility. But of course, if you do it, I think you will be the first one to demonstrate this kind of a capability.
Yeah, yeah, great, great. Yeah, definitely. We will take a note and we will pass it to our R&D team to think about it.
Uh, Maybe I can quickly answer this question.
Yeah.
I think so. Certainly, when you take this sunflower stalk with the outer layer and a soft spongy layer, uh, of course, you can do cryomilling, and but the product will be, it will be really heterogeneous also. I mean, it may be, the particle size will be quite uniform for both the outer layer as well as the inner layer, but one has to really perform multiple runs in a pyrogc mass spec to evaluate the consistency of your results. But otherwise, if it is possible to, separate the hard outer layer and the soft inner layer, then that might also be a good way to initially separate them and then subject them to a cryomill for more homogenization. But of course, if the panelists have any other responses, I think, please.
Yeah, I think what you have said is the best one, I think, yeah, because we have not tried this kind of sample, so your experience really count on that. Yeah. Okay, so that's one question from Atta Mayer, I think. Do you have any more question? Maybe Asti?
Oh, we have two more questions. This is the last two.
Okay, we have many experiments. Yeah, I think this is a very difficult question to answer. As I said, the other alternatives, you gain the expertise through experience, okay, where you can really make sure that you are able to get the best sample for your analysis. But if you have cryomill, that really simplify the workflow for users. Yeah.
Yeah, I would also like to add that certainly for samples that are more organic in nature with very less amount of inorganics, I think cryomilling will certainly help to give you repeatable results. And of course, you can always duplicate it for one sample and verify that if it is okay, and then you can simply go ahead with it. But for heterogeneous samples, like the biomass question that was asked earlier, yes, even cryomilling, one has to verify that, and also you might have to run a few runs to verify how homogeneous the sample is. But of course, as Karthik said, based on experience, also you can kind of cut down on the number of experiments that you do with PyroGCMS. So typically we end up doing multiple experiments and essentially understanding the error bar or the standard error around the individual compounds, and later we try to get a hold on that and then try to minimize the number of repetitions.
Yeah, let's move on to the next question.
Actually, there will be like a recording will be sent to the email.
Yeah, so we will try to share the PowerPoint after removing some confidential information. Yeah, we will try to share the PowerPoint slides to the participants. Yeah. Okay, I think there's one more question. Last, maybe I can read and we try to answer it. This is from Atta Mayer. Can we perform pyrolysis on substrate? Okay, so when you say substrate, and what kind of substrate, something I'm not really sure. But Prof. Vino, you have any idea? So, and because
I don't know. Even sometimes the sample is a substrate. Sometimes the
yeah,
biomass or the plastic that we use can also be a
so
substrate. But if the question is more from a biological background, then a substrate is something that is more biological in nature.
yeah,
It could be like
people have done PYGCMS of algae also.
yeah. So
Even
if
other.
the substrate is organic in nature, why not? Yes, we can certainly perform PYGCMS of such substrate. So we also
Yeah.
have some experience doing such things like
Okay.
proteins, carbohydrates, lipids.
Okay.
If these are going to be some substrates for some microorganisms, yes, we can do PYGCMS of these compounds.
Okay, maybe he has clarified his question. So coating substrate. Okay, so I think that's definitely is possible because our system is suitable for paints and coating material analysis. So definitely, yeah, you can do the substrate separately, and you can also do it together with the coatings. Yeah, so I think we are just completed 2 hours. Maybe, Chairman, is it okay we wrap it up and close, uh, or you
Oh,
have
sure.
any?
Um, no, maybe one last question to close. I think this may be relevant to many users of PYGCMS as well. I think with the surge in the helium prices, I think it's sometimes getting not affordable for labs, especially in the universities, to go for a costly helium gas, which is the key thing for a PYGCMS analysis. And I'm sure you also know that many are shifting to hydrogen-based carrier gas systems. So, what are your thoughts on shifting to another carrier gas like hydrogen? Maybe I would request Michael Saul to give his views on this.
Um, Yes, it is possible to use hydrogen as carrier gas, but you have to consider, of course, some precautions. I mean, safety things. For example, pyrolysis temperature should not be above 600 degrees Celsius because of the self-ignition point of the hydrogen. And we also have even a kind of a document also for the other accessories what we are providing, how to deal with hydrogen. But there is a clear but at the end of my sentence. What we know is, and what we see is, we see a quite significant drop in sensitivity. It has to do with the lower um, efficiency of hydrogen as a carrier gas. And so that means helium gives the better, I mean, maybe 30% better sensitivity. And if you're going to perform a trace analysis, it can be a big factor. So, and of course, you cannot use the hydrogen together with the autosampler because it will be a big volume of hydrogen, and that is another issue since we always have this flow, this what is it? A venting of the system with a carrier gas. And if you use nitrogen for the pushing out the sample cup, then it's also reaching by this design the MS detector, and you have another drop of sensitivity. So yes, but it is a compromise, and you have to deal with less sensitivity. That's what I heard from our customers. So that's my answer for that.
Got it.
Yes, as Michaelson mentioned, it's exactly the same what we have seen in the case of Indian customers also. There are few customers who are like, facing this crisis of helium and they want to switch to hydrogen as carrier gas, and there are limitations exactly to true call to say there are limitations.
Okay, thank you. I don't have more questions. So of course, again, thank you very much for the opportunity, organizers, and especially Karthik. And yeah, I look forward to tomorrow's event as well. So I pass it on to uh, Damayanti.
Thank you, Professor Finu, and thank you to all participants. We have some fantastic engagement today. As we approach the end of our webinar, I'd like to take a moment to thank you for Dr. Michael, Ms. Anusa, and Dr. Karthik for their valuable insights and time. And also, I would like to remind everyone that registration for the second day of our webinar is still open. To register, simply use the same registration link and scroll down and choose the July 20th. We look forward to your participation on the second day as well, where we will cover more exciting topics and insights. Additionally, please take a moment to fill out our feedback form. which will be available in your inbox after the webinar. Your feedback helps us improve and provide even better content in the future. Thank you once again for joining us today. We hope you found this session informative and valuable. Have a great day, or afternoon, or evening, and goodbye. Thank you.
Thank you.
Thank you.
Bye.
Bye.
Thank you all. Have a
Bye.
great day.
Thank you so much. Have a great day.